Hello friends, welcome back. Let us continue with the module of electrician trade. I am Rajiv. On behalf of Nimi, I will be guiding you through this exercise of service and repair of electric iron, electric kettle, cooking range and geyser. Service and repair of common household appliances like electric iron, kettle, cooking range and geyser is expected of an electrician. In this exercise, we will cover that. On completion of this exercise, you will be able to repair and service of electric iron, repair and service of electric kettle, repair and service of cooking range, repair and service of geyser. Ensure safety by wearing proper attire, goggles, gloves and boots. The necessary tools or instruments required for this experiment are as follows. Spanner set 6 to 22 mm 6 numbers, Mega 500 volts, digital multimeter, electrician toolkit. The equipment or machines required are automatic electric iron box 750 watts 250 volts, kettle 500 watts 250 volts, electric cooking range 1500 watts 250 volts, geyser 1500 watts 250 volts. Other materials required are kettle element 500 watts 250 volts, asbestos sheet and fiber washers, test lamp 100 watts 240 volts, element suitable for available cooking range 1500 watts 250 volts, geyser heating element 1500 watts 240 volts, geyser thermostat, 3-core flexible cord 15 ampere 3-pin plug, insulating material such as asbestos and mica sheets suitable for electric iron. This exercise will be split into two parts. Part 1 will comprise of service and repair of electric iron and electric kettle. In Part 2, we will cover service and repair of cooking range and geyser. Let us start with the testing and repairing of electric iron. When electric current is passed through a coil in the electric iron, the coil becomes very hot. Through conduction, the heat is transferred to the flat base plate. An electric iron consists of handle, sole plate, pilot lamp, heating element, thermostat and thermal fuse. The thermostat uses bimetallic strip which is made up of two different types of metals, brass and iron. In the presence of heat, the bimetallic strip expands differently, causing the action of power cutoff indicated by neon light off. Similarly, when the strip cools off, the bimetallic strip regains its shape and the power turns on the neon light indicating heating. Remove the electric iron from the power supply. Observe and record the nameplate details in the inspection sheet such as voltage, current, capacity, wattage, etc. Next, conduct a visual examination of the power cord and plug head. Open the cover of the electric iron. Conduct a continuity test between the terminals of power cord and electric iron with the help of a multimeter. Replace cord if necessary. Check earth fault by inspecting the insulation resistance between the line terminal of the iron and the body of the iron with the help of a Mega. Record resistance measured in table. If earth fault occurs, the reasons are insulation failure, broken parts, damaged thermostat, switch actuator. Rectify the fault by replacing defective part. Now, check the heating element by measuring its resistance with a multimeter in normal condition. Set the multimeter at the resistance setting and connect its leads to the terminals of the heating element. If the meter reads resistance values within 100 ohms, then the element has continuity and it is okay. If the meter doesn't read any values, then the heating element is defective and it is to be replaced. Check insulation resistance between earth and neutral terminal with the measure. Check for continuity of thermostat and heating element. Rectify the fault by replacing the defective part. If open element in circuit occurs, check the thermostat, indicator bulb circuit and element. Connect the series test lamp to the element circuit, shorting the contact of the thermostat. If the test lamp glows, the thermostat is defective. Connect the terminals of the indicating bulb with the supply. If the test lamp glows, the trouble is not in this section. Short the terminals of the element. If the lamp glows, the element is open. Replace the element. Let us check for failure of temperature setting controller. Check for actuating mechanism by heating thermostat with external heating device. If it is okay, assemble the iron and test its working. This concludes the service and repair of iron box. Our next testing appliance is electric kettle. An electric kettle boils water in a short span of time. Kettle comes with the feature of auto shut-off. Overboiling does not occur as it switches off as soon as the water starts bubbling. Inside each kettle is a metal coil that converts current to heat. When the kettle is turned on, a large electric current flows through the coil or the heating element. The coil has an electrical resistance. This resistance turns electrical energy into heat. The heat brings the water inside to boiling point. Kettle's thermostat prompts to switch off when water reaches boiling temperature. Check the nameplate details of the kettle and record them in the information sheet such as voltage, current, capacity, wattage, etc. Disconnect the electric kettle from the supply. Read the assembly diagram in the instruction book of the kettle and dismantle the parts in the sequence recommended by the manufacturer. Disconnect power cord and check continuity. Visually inspect and test with the multimeter for any contact of live wire with the body. Check insulation resistance between socket terminals and the body of the kettle. If this resistance is less than 1 mega ohms, kettle element should be replaced. Check the continuity of the ohmic value of the heating element by connecting to the multimeter or test lamp. If there is no continuity, the element is assumed to be open and replace it with a new element. Check each part for defect and if okay, reassemble and test it. Kettle should only be switched on if there is water inside. This concludes the service and repair of electric kettle. We end the part 1 of this exercise here. We will continue in part 2.